Assalamu alaikum, dear students. Today our topic is compounds of phosphorus, in which we are discussing phosphorus halides. और कल PX3 में PCl3 हमने डिस्कस किया. Now phosphorus pentahalide, that is phosphorus pentachloride. PCl5. Preparation. It is prepared by the reaction of red phosphorus, white phosphorus, with excess of dichlorine. So we will take phosphorus, white phosphorus, and we will take chlorine. We get PCl5. तो हम बैलेंस करेंगे. phosphorus चार्ज है, we have to multiply it by 4. 4 5s are 20, Cl20, so we have to multiply it by 10. So the first method of preparation is by the reaction of white phosphorus with excess of dichlorine. This is number first. And number second, by the action of sulfuryl chloride. In PCl3 we are taking thionyl chloride, now we are taking sulfuryl chloride. On white phosphorus. So for this the reaction is that we will take P4SO2 Cl2. In the preparation of the PCl3 we were taking thionyl chloride SOCl2. Now in the preparation of phosphorus pentachloride we are taking this sulfuryl chloride SO2Cl2. For ryl chloride. So it forms PCl3, PCl5 plus SO2. So we take 4 times, 4 5s are 20, we will take 10 times. Now we have to take this sulfur dioxide also 10 times. These are the two methods of the preparation of this phosphorus pentachloride. Now we will take properties. PCl5 is yellowish powdered solid. So its chemical properties are: number one, hydrolysis, it gets hydrolyzed by the moist air, or we can say that it fumes in the moist air. And it first, on hydrolysis, it first forms POCl3, phosphorus oxychloride, and then again with the excess of the water, it then forms phosphoric acid, H3PO4. Now P4 plus H2O, it forms PCl5, it forms POCl3, POCl3 plus 2 HCl. This is phosphorus oxychloride. Now again this phosphorus oxychloride, it reacts with the water, it forms H3PO4. This is H3PO4 plus HCl. This is phosphoric acid. Now here we will balance it, we will take 3 diamonds, that is H3PO3 or 1,4. Now phosphorus will khatam. Now we have 6 times hydrogen, 3 times hydrogen यहाँ पर हमने ले लिए. Now we have 3 hydrogen left here and 3 Cl, this is hydrogen chloride 3 times. Now this is how it gets hydrolyzed. Now next property is the reaction of PCl5 with the compounds containing OH group. So next is a reaction with compounds containing OH group, like carboxylic acid and in carboxylic acid we will take acetic acid, or alcohols. In the alcohols we will take ethanol. So it reacts with the organic compounds containing OH group, converting them into the chloro derivatives. It reacts with these compounds containing OH group and converting them into halogen derivatives and converting them into the, since we are taking with the Cl, into chloro derivatives. For example, we will take CH3COOH, acetic acid plus PCl5. Now when these react, they form CH3COOCl, CH3COl plus POCl3 plus HCl. CH3COCl, CH3COCl, PO plus POCl3, POCl3 plus HCl. Now we have to balance the reaction, and you see that the reaction is almost balanced. CH3COCl plus POCl3 3 4 और 5 Cl, फास्फोरस 1 फास्फोरस 1 Cl 1 2. Now Cl 1 2 and 3 5, CH3 CO Cl आगे 3 4 5 फास्फोरस 1 फास्फोरस 1. This is CH3COCl is acetyl chloride or acid chloride. Acetyl chloride or acid chloride, and this is phosphorus oxychloride. Similarly, if we take C2H5OH, ethanol plus PCl5, it reacts with it and it forms C2H5Cl plus, तो एक Cl निकल गया, प्लस POCl3 हो गई 3 और एक 4 Cl, अब एक Cl रह गया और यहाँ पर एक हाइड्रोजन प्लस HCl. This is ethyl chloride. This is the reaction of PCl5 with the compounds containing OH group, reaction with metals. If we take finely divided metals, on heating with PCl5 form their chloride derivatives. They react with the PCl5 and they form their corresponding chlorides. Finely divided metals on heating with PCl5 and form their corresponding chlorides. For example, if we take silver and allow it to react with the PCl5 and we allow it to heat, we will heat it, it forms AgCl plus PCl3. So we will balance it, PCl3 twice Ag twice Ag. Now twice Ag if you will see, तो जो सिल्वर जो है वो 2 times, वहाँ पर भी 2 times, और PCl3 जो है 5 2 and 3 5. This is silver chloride. And if we will take tin and allow it to react with the PCl5 on heating, it reacts with it, it forms SnCl4 plus SnCl4 plus PCl3. So on balancing the equation, जो Sn हम इसको अगर हम 2 times ले लेंगे, this is 2 times 6 times Cl, 4 times Cl हो गया 10 times Cl, phosphorus 2 times 2 times 10 1 time, and Cl 4 times 4 and 6 10, 2 5s are 10. Now next, number 4, on heating PCl5 sublimes, but on strong heating it decomposes. So if we write the reaction PCl5 on heating forms PCl3 and chlorine is liberated. Now if you will see this reaction, it is already balanced. Phosphorus pentachloride upon heating forms phosphorus trichloride, and this is chlorine. These are some of the important properties. Now the structure of PCl5. In liquid or gaseous phase, PCl5 has trigonal bipyramidal structure. So this is phosphorus, and we will take Cl, Cl. So in PCl5, when we take PCl in the gaseous or in the liquid phase, it has trigonal bipyramidal structure. We have, these are three equatorial bonds, PCl, PCl and PCl. We have three equatorial bonds of PCl between phosphorus and Cl, and two axial PCl bonds. Now these three equatorial bonds are equivalent and they have a bond length of 202 pm, whereas the axial bonds are equal and their bond length is longer than that of the equatorial bonds, that is three equatorial bonds. This PCl and PCl, these are the axial bonds. The bond length is 250 pm, whereas the equatorial bonds, which are equivalent, the length is they have the length of 202 pm. This is due to the fact that these axial bond pairs, they experience more repulsion as compared to these equatorial bonds. And if we take in the solid phase, this PCl5, it exists as an ionic solid. It exists as an ionic solid which has a formula of PCl4. This is anion, and PCl6. This is the cation. This is the cation and this is the anion. Anion has another anionic part and this is cationic part. And this PCl4, which is the in the cation, PCl4 is cation, PCl4 is tetrahedral and anion PCl6 negative is octahedral. This is the structure in the solid state, in the solid phase, and this is the structure when we take PCl5 in the liquid or in the gaseous phase. So for today we have this phosphorus pentahalide or phosphorus pentachloride. Thank you.